Docker is a tool for running apps within containers that provide an isolated environment. Containers are similar to virtual machines, but containers contain a lighter stack. VMs encapsulate entire operating systems, including kernels, whereas containers borrow from the underlying OS the container is running upon. This makes containers lighter, faster, and more agile. Containers run just the code, configuration, and dependencies that your app needs to run. Containers are built from images. You can pull pre-built images from Docker repositories such as the official hub.docker.com or roll your own using something called a Docker file. Containers are a great tool for developers as we can fire up and tear down apps quickly, neatly and efficiently without polluting our development environments. They are also an excellent solution for production platforms. If you get a container working on your own machine, then in effect it will work pretty much anywhere, meaning you could relatively easily migrate your production containers running in, say, AWS over to Azure and know that your containerized apps will work the same way on both cloud platforms. Here I'm going to show you how to containerize a simple Hello World app in just a few minutes. To get going, you will need Docker. So head over to docker.com and install Docker. Once installed, type, you guessed it, Docker. And you should see a list of commands that proves that your Docker CLI is working. Next, we'll create a simple app to test our Docker container. In your favourite code editor, in my case VS Code, I'm going to create a simple index.php file. In here, just a couple of lines of code. Save the file and create a new file named Dockerfile in root. A Dockerfile is a simple text file that holds instructions that tell Docker how to build our Docker image. Before we populate our Docker file, head over to hub.docker.com and search for the official PHP Docker container. You may need to create a free account and log in before you can perform a search. Click into the container listing and you will see a list of Dockerfile links. For our example, we need our container to run a web server that supports PHP. We will choose an Apache stretch Dockerfile to add our container stack dependencies. Armed with this information, we can now update our Dockerfile. When we perform a Docker build to create our Docker image, this Docker file will perform 3 tasks. 1. Pull the requested Docker Apache image from Docker Hub. 2. Copy all local files in AppSource into our Docker images directory. And 3. Expose port 80. Let's build our Docker image, not forgetting the trailing full stop, or period if you're American. -T gives us a tag name so that we can easily identify our image. And not forgetting that full stop. Once built, we can list our local Docker images by running docker image ls. ls for list. And here we can see our Docker image. So that's our Docker image built. Now let's run our Docker image within a Docker container. 2000 is our local port, 80 is the container's port. So this Docker command tells Docker to launch our Docker image into a Docker container and bind local port 2000 to the container's internal port 80. We can now test our Docker containerized app by pointing a web browser to localhost :2000. This is all good and well, but every time we wanted to modify our app, we would have to rebuild our Docker image. So that we can build out our app without constantly rebuilding our Docker image, we can map a local volume into our image volume. From your command line, hit Ctrl+C to shut down your running container. Now run your container again using an additional volume flag. This maps your source code's path into your image's source code path. On my system, I would run my container as follows. And here I'm mapping my local volume into my images volume. Now we can update our index file and see changes instantly without having to update our Docker image. And if we reload, we can see that those changes have been instantly applied.